Now we've been doing integration by parts and substitution together. There are many problems where you have to use both. But among them, there's a special situation when you have ln of x in your integral. In that case, you have to know this trick of doing the substitution. So let me give you an example here. Say you have integral of x times ln of x squared dx. Whenever you have an integral that has ln x involved, you can almost always, maybe there are a few outliers, but in most cases, just setting u equals to ln of x will simplify the situation. Now, if you do that u substitution, you don't want to differentiate like this, but rather you want to exponentiate both sides. What is e of ln of x? They just cancel, right? Yeah. So you just get x. So you have e to the u equals to x, and then you want to apply the d. Okay? If you apply d to e to the u, what do you get? Derivative of e to the u is e to the u attached with d of u. And if you apply d on the right side, it's just dx, right? Okay, so this much format will always be the same once you take u equals to ln of x. You always want to go by this way. Okay. Now, let's try to change things. So x is what? X, according to here, it's e to the u. What's ln x? U. And there's a square, so it's u squared. What's dx? E to the u du. All right, now what? Here you have to use the exponential rule to simplify, because if you don't, then it becomes unmanageable. So what you want to do is think about what e to the u times e to the u is. Right, because if you have the same base, the exponents add up, right? So you end up with e to the 2u. And therefore, the above becomes integral of u squared times e to the 2u du. Okay, so that tells us we must be using what rule? What method should we integrate by parts, right? So we use integrate by parts with, on the d side, you put u squared, integral side e to the 2u. U squared differentiates to 2u, differentiates to 2. It hits 0, so you stop. What's the integral of e to the 2u? 1/2 e to the 2u, thank you. Integral again. Another 1/2 will come out, and you get 1/2 times 1/2, which is 1/4. Another integral, 1/8. Then you get plus, minus, plus, minus. Then you go like that. 1/2 u squared e to the 2u. This gives you negative 2 over 4 u e to the 2u. This gives you 2 over 8 e to the 2u. And the last line has to be multiplied and integrated. But integrating 0 will just give you a constant c. Adding everything gives you the result of the integration by parts. So this now becomes 1/2 u squared e to the 2u minus 2 over 4 reduces to 1 over 2 by dividing 2 top and bottom. 2 over 8 reduces to 1/4. And then you have e to the 2u plus c. And this is still not an answer. Why?
You have to plug it in.
You have to plug in it, yeah. But it's better to factor e to the 2u. Okay? So let's factor e to the 2u first. So it's 1/2 u squared minus 1/2 u plus 1/4 e to the 2u plus c. And now we plug in, u is ln of x, so it should be 1/2 ln of x squared minus 1/2 ln of x plus 1/4. And e to the 2u is e to the u squared, right? What's e to the u in terms of x? It says e to the u is x, right? E to the u is x. Therefore, this must be just simply x squared plus c. Done.